All right, so here we have the notes for section 1.3, the 12 basic functions. So these are the list of the most basic types of graphs that you will potentially see. So across the top row, you have the identity function, which is just f of x equals x. You have the squaring function, which is x squared, the cubing function, x cubed, the reciprocal function, 1 over x. And then the second row, you've got the square root function, which is root x, the exponential function, which is e to the x, the natural logarithm function, which is ln, or the natural log of x, the sine function, sine of x. Then on the bottom, the cosine function, cosine x, the absolute value function, so the absolute value bars of x. Sometimes you'll see ABS. The greatest integer function, intx, and the logistic function 1 over 1 plus e to the negative x. Now, just a note about the greatest integer here. What the greatest integer function does is it rounds all values down. So any decimal value is rounded down to the previous number. So 1.1 rounds down to 1, 1.5 rounds down to 1, 1.9 rounds down to 1, 1.9 repeating rounds down to 1. So all values round down. All right, so we have our examples. So for example 1, it says 9 of the functions have domain the set of all real numbers, which do not. So the set of, what that means is that the functions are allowed for all x values. So 3 of them, you cannot plug any number in for x that you want. That is the reciprocal function. You can't use 0 because reciprocal is 1 over x. So if that's my function, I can't plug 0 in for x, so I can't use all the numbers. The square root function, that's not how you spell square, which is root x, you can't plug negative numbers in. And the last one is the natural logarithm, ln x. The natural logarithm cannot be done on negatives either, so just like the square root, x has to be positive. Now for the square root, x should be negative, but the natural logarithm can't be negative. So for this one, x can't be 0. For this one, x must be greater than or equal to 0. And this one, x must be greater than 0. So since you can't use all of the numbers, those are the 3. So the second one there, one of the functions has the domain the set of all real numbers except 0. Which function is it? Well, we just talked about that. That is the reciprocal. Can't divide by 0. Which 2 functions have no negative numbers in their domains. So once again, square root, and the natural log of these, which one is defined as 0? So the square root is defined as 0. You can take the square root of 0, which is what means defined. So example 2, only 2 of the 12 functions have points of discontinuity, or those points in the domain of the function. So discontinuities are breaks in the graph, a place where the graph jumps or comes apart for some reason. So that's the reciprocal, and it's the greatest integer. If you look at the graphs, they have breaks in them. Are those points in the domain of the function? For the reciprocal, no. 0 is not in the domain, and that's where the break is. For the greatest integer, yes, it is. If you look at the picture, you have closed dots, which means the value is there, and open dots where the value is not. So there's always a closed dot over an open dot, which means all x values are covered. Example 3, only 3 of the 12 basic functions are bounded above and below. Which are they? So that means they have a maximum and a minimum value. So the 3 of them are the sine function, the cosine function, and the logistic. All of those graphs never go below a given value or above a given value. For sine and cosine, it's -1 and +1. They never go below -1 and above +1. For the logistic function, it never goes below 0 or above +1. For example 4, 3 of the 12 basic functions are even. Which are they? So even functions are mirrored across the y-axis. So they're the same on the left as they are on the right. So the 3 of them are the squaring function, same left to right. It is the cosine function, same left and right, and the absolute value function. It is the same on the left and on the right. All right, so let's see here. So it says graph the function y equals x minus 2 squared, then answer the following questions. All right, so real briefly, that's going to be, so that bottom point there is at 2, 0. It's a parabola opening up. Okay, so on what interval is the function increasing? So that means where is the values rising? Now when you look at increasing, decreasing, you're reading the graph left to right. So I'm coming down, and then I hit 2, and I start going up. So the interval is increasing is x is greater than 2, or if you want to write it in interval notation, it would look like that, from 2 to infinity. Is the function even, odd, or neither? So an even function is mirrored across the y-axis, so it's not even. An odd function is mirrored upper right to lower left. It's not that. So the only one left is neither. Does the function have any extrema? So extrema are maximum or minimum values. This is yes. It has a minimum at the point 2, 0, the bottom of the parabola. How does the graph relate to the graph of the basic function y equals x squared? It's moved right 2 units. That's it. Okay, example 6, which of the 12 basic functions has the following piecewise definition over separate intervals of domain? So we'll graph it real quick. So remember f of x is y, so y is equal to x if x is more than 0, so that is that line. It's equal to negative x, which is that line. That is the absolute value function. Okay, example 7, using the basic function of this section, construct a piecewise definition for the function whose graph is shown below. So I have 2 pieces. I have that one. I have that one. This is a piece of the square root function. This is a piece of the squaring function. So I'll have f of x equals, now we do a piecewise, it's the left piece first, so the squaring function is x squared, square root function is root x. Now I also, though, like up here, I need restrictions. So the squaring function is good when x is less than 0, so we'll put less than 0 here, and this one will be greater than or equal to 0. Now you could move where the or equal to bar is. You could put the or equal to bar with this one, but not with this one, just not on both of them at the same time. The second part is the function continuous. That means, can you draw the graph without having to lift your pencil? So yes, it is continuous, because I can trace along the graph without having to lift my pencil. Okay, example 8. Does the graph of y equals ln x have a horizontal asymptote? So that's the natural log function. It looks something like that. No, it does not. Now, it may look like it does. The graph, if you extend it, does start to slow down, but it never actually, it'll always keep growing just very, very slowly. It never will max out. So the last one here, give a complete analysis of the basic function y equals the absolute value of x. So for complete analysis, you were talking about the domain, the range, whether it's where it's increasing, where it's decreasing, x-intercepts, y-intercepts, maxes, mins. Okay, so we'll real quick sketch the graph over here. So the absolute value of x looks like that. So the domain for the absolute value of x is all real numbers, written in interval notation, that is negative infinity to positive infinity. The range is, so this graph never goes below 0, so y must be greater than or equal to 0, or written in interval notation, 0 to positive infinity. Where's the graph increasing? The graph is increasing when x is more than 0, the right half. So once again, in interval notation, that's 0 to infinity. Where's it decreasing? Left of 0, so x less than 0. So that'd be negative infinity up to 0. Now if you notice, there's no or equal to bars here, because at 0 it switches between the two, so it's neither increasing nor decreasing. X-intercepts, or what value for x does it, or is, sorry, where does it cross or touch the x-axis? So that happens at x equals 0. The y-intercept, where does it touch or cross the y-axis? That also happens at y equals 0. It's that point right there. The maximum is the largest value this graph takes. This graph does not have a maximum value. It goes up forever. The minimum is the location of the lowest value, which happens at 0, 0, the bottom of that curve. And that is all for this section.